I think we're actually live now. I'm just gonna wait for the YouTube confirmation. But hello to everyone who's like early here. I will start the stream soon. Just gonna drink my bit of water. Fortunately, no Coke Zero tonight. Yeah, just waiting a little bit for the YouTube confirmation here from analytics. No, does OBS say we're streaming? Yes, it does. It says we're streaming. And is my audio good? Yeah, I'm gonna check now. It does. It says we're streaming. Nice. You guys, I hope you guys can hear me a little bit better than the last stream. Reason being is because I've got the microphone a little bit closer to my face, so you can actually, hear it right from the horse's mouth, right? That's a phrase I've been using quite a lot recently. I'm also going to keep the window open, so you might hear some train noises, some fireworks or something. It's because it's very, very hot in the UK, so we're going with that today. But anyway, it's good to be back. It's good to be here with you guys, and especially for those watching in the future. I hope you stick on for the entirety of the stream. We're going to be doing some interesting stuff. Again, we're going to be working mostly on the May ECS project. So let me just open that on code. And specifically today, we're actually going to try and add a few assertions, or a few debug time assertions on our code, because I've realized that most of this implementation here makes very good assumptions sometimes, but it doesn't specify that we make, for example, unique pointer assumptions, we make iterator assumptions and stuff like that. Which means that we could potentially have bugs in the software. Now, I know that we probably don't, because I've tested this quite a bit now, but it's always good to use assertions whenever you can, right? And this is basically going to be, I guess, the bulk of the stream today. We're just going to be asserting some of the code with the Microsoft guideline support library. So for those who don't know, I'm not sure if there's anyone watching actually right now, but Microsoft has this implementation of the GSL, which was released, I guess, quite a while ago now, 6 years ago. It seems that's well, I'm not actually sure if it's the earliest. There you go, 7 years ago. I guess 7 or 8 years ago. Where this library is basically intending to support the C++ core guidelines, right? And if you guys are into C++, if you want to write sort of clean, understandable, and let's say bug-free code in C++, you should at least give this page here a read. And this is basically a must read for anyone who's really serious about doing C++ in a professional setting. So the C++ core guidelines is essentially just a one-page article, which was written by Bjarne and Herb Sutter, sorry. And these guys are obviously very, very big in the C++ community. Bjarne himself wrote the language, or wrote the very first few iterations of it, and is still a very good contributor to the language. Herb Sutter, I believe he works at Google, and he oversees all the C++ stuff in there. So this article has very, very good recommendations for how you can write very, very good C++. C++ code that's going to last for ages, C++ code that avoids certain undefined behavior and bugs. So yeah, give this a read. And more specifically, let's see if I can go back to the stuff here. We're going to be looking at assertions, right? So expect here. And let's just give that a read so we know what we're working with today. Prefer expects. There you go, prefer expects, this section here. So let's just read this and then try to make sense out of it, because I think it's worth it for the people watching this in the future. So if you guys are learning C++, this section is going to help you quite a lot to make assertions in your code, precondition assertions, postcondition assertions, that will essentially make it clear, or make the implementation clear, what conditions you expect for a particular function, a particular class to meet, or a particular piece of code to meet before you actually run it. So yeah, let's start from the top here. So prefer expect for expressing preconditions. Reason: to make it clear that the condition is a precondition and to enable tool use, right? Why is that open? So example, let's look at this example here. So we've got this function which calculates an area. So area takes two integers, a height and a width. And the very first thing that we do in that function is we expect that the height is more than 0 and the width is also more than 0, right? Which makes sense. If you're calculating an area and you want the results of that area to actually make sense, you expect these values to be positive, correct? So this is essentially what this is doing. This piece of code is crucial. So this line of code is crucial because it tells the programmer straight away that this function only makes sense when you call area with height and width. But more importantly, in most settings, in most tools that provide this definition expects here, this will actually not crash your code, but it will terminate your code if these conditions are met. So your program stops right there and then, and you know exactly which line of code, exactly which area of the code kind of doesn't work, right? So what you know, maybe you have a bug in your implementation somewhere, maybe you're passing values that don't make sense. And this is what it helps you with, right? This is essentially it. And yes, you could do this at runtime as well with something like this. If height is less than 0 and width is less than 0, that's valid as well. In fact, if these two values are kind of user specified, so if the user actually is putting these values through the program somehow into this function, then you should probably do this check here with an if statement, just so you can catch the errors at runtime. But if error is only being used in sort of like your implementation details, right? So if there's no user input here, you're just calling this function as a kind of helper to another function or something like that, then you want to make sure that wherever you are calling area, the preconditions are met. And yeah, there's more reasoning here, so let's read it. So long story short, this is what we've just talked about. There's not too much apart from this. But note, preconditions can be stated in many ways, including if statements and assert. So assert is actually part of the language, part of the C++ language. I think it's if you hash include C assert, you get this definition here, which is basically a macro that does the same thing. This can make them hard to distinguish from ordinary code, hard to update, hard to manipulate by tools, and might have the wrong semantics. Do you always want to abort in debug mode and check nothing in production runs? And yeah, this is the thing with assert, right? So when in C++, when you're using assert, it really just works in debug mode. So basically, it disappears in release. So the code still runs in release if you don't have, I think it's ndebug, that's the flag that makes this work. But with the use of expects, with the use of Microsoft's expects function here, you can configure that. So maybe at debug time, it will terminate your program as it should. But at release, you may want this to kind of throw an exception or throw an error, right? And you can do that with expects, and you can't do that with assert. That's why you kind of use expects over assert here. Preconditions should be part of the interface rather than part of the implementation, but we don't yet have the language facilities to do that. Yeah, this is just saying that C++ doesn't actually have, expects it as part of the language, which is fine. We're going to do this with Microsoft GSL today. And there's a bunch of other stuff here. So I highly recommend reading this. I highly recommend understanding why, it's good to use expects in your code, especially when you have things like this, where a bit of code may not make sense to run if one of your preconditions are met, right? This is essentially it. And how can we actually use expects here in C++? So this is one of the things we're going to be doing in the stream. And we're going to basically have access to expect by using the Microsoft GSL, right? So GSL stands for Guidelines Support Library. And it's essentially Microsoft's own implementation of the guidelines support here, which, are things described by this document. And it provides a bunch of really, really useful stuff. Right, so you can see here we have obviously the assertions, which contains expect and shows. We also have types here that are available actually in more modern versions of the C++ standards, such as byte. It does have containers like spam as well. So if you look at spam here, spam, let's see if we get that. So these are like views, right? They're not really containers, they're just views into things, which obviously you have with std spam in C++ 20. There is a difference. Apparently, GSL spam enforces bounds checking. So, you know, if you try to access something that's not part of your view, or if you go outside of it, GSL spam will probably like throw something or will tell you otherwise. But it's a very nice way to get some of these newer C++ features into older standards. So, for example, I've worked in many companies where we were compiling with C++ 11. And we didn't really have access to things like spam, things like expect. So all you basically have to do is to, well, add this library as a third-party package, and you have access to all these things, right? So let's begin with that. Let's begin by adding Microsoft GSL into our build, okay? And one way you can do that is through fetch content, I believe it is. And there is a section here on the Microsoft GSL repository, or the README file, where it explains how you can basically include the library through CMake, right? So that's what we're going to do. We're going to add this into our build. And it's not too difficult. Basically, we just got to go into the main CMake lists. Let's have a section here where we actually add all of the fetch content stuff here for Microsoft GSL. So I do have a Conan file as well, which is interesting. What do I actually have here? Oh, yeah, I know, because I have a Conan file. I forgot about that. I forgot that I have Conan in the build. Yes, you can absolutely do this with CMake alone. But since we have Conan already, let's go into the Conan IO and find Microsoft GSL in there, because I'm pretty sure that there will be a version in here. So Microsoft, let's just search for that, or maybe just GSL. So GNU Scientific Library, that's not what we want. Microsoft's implementation of the guideline support. This is the one we want here. So we're going to include this into our Conan file, and we're going to have to basically do a Conan install again. So again, we're going to go in here. We're going to keep this nice and tidy in terms of alphabetical ordering. And I'm hoping that you guys can see the screen. If you guys can't, please let me know in the chat. So yeah. And we're obviously going to install this now. Let's install this whole thing. I expect to be pulling Microsoft. There you go. So we've already got a pre-built binary from Conan. We don't have to build it ourselves. Amazing. And now we should be able to include GSL somewhere, right? So is there actually a snippet of code where it shows how to include it? There you go. Microsoft.gsl. This is what I'm looking for. And this is what we're going to include in the CMake lists. So we add subdirectory there, and because it's mostly going to be going into the actual engine, my ECS engine here, I'm going to add it to the CMake lists, which is here. So there you go. We're going to require that. And it's Microsoft GSL, that's the target name. And I don't expect to have any issues here. This should just work, right? Hopefully. Maybe I have to reconfigure the cache. Let's see. So right, it didn't actually find it. As usual, this is just, I guess this is just part of the experience of Conan now. So by not providing Microsoft GSL, I'm wondering if we installed the right stuff though. So which one did we actually install? We installed it in release and we're running in debug, that's why. So if I install the library in debug mode, things should work. Okay. Okay. Now things have changed. Let's reconfigure this. And great, you found GSL somewhere. Declared raylib. Found Microsoft GSL. Amazing. And just like that, we have Microsoft GSL installed or integrated into our build, right? So essentially, we should be able to now come in here and do something like include. Is GSL in here? Microsoft GSL or something? Yeah, see, because I'm using CMake, sorry, C++ modules, the IntelliSense doesn't quite work, which is still something I'm going to complain about in every single stream, but yeah, it is what it is, right? So now let's see in the actual usage how we can include assertions. So maybe there will be something in the assertions page here. And yeah, welcome to everyone who's watching this. I don't think we have too many people now. We've got 2 people watching, so very good evening to you, sirs, and I hope you stick around for the journey. Right. Is that really no example here? Include boost, include arrow streams, stadogs. We will find an example. Come on. It does bother me how, you know, a library as popular as Microsoft GSL doesn't really have like a very easy to read example of how to use some of the stuff. But oh well. Yeah, I'm pretty sure it's gonna be like GSL assert or something. Is that? Let's try and build this and see what happens. If not, we can go like and scan on the there you go, GSL assert. GLS. Yeah, GLS is not a thing. GSL. Let's build that again. Yeah, so that actually did seem to build, and yeah, this is the header we have to include. I just vaguely remember using this before, so it is what it is, right? So yeah. Now, because this is a third-party library, I'm gonna add it right here. So here are my system, or the C++ include directories, and then I've got my third-party packages up here. Okay, so now I expect to have access to, for example, expects, right? Expects. So if I just do this, does this build? Great, it does build. And IntelliSense doesn't quite work. You know, as I said, we're using C++ modules, not quite yet supported very well anywhere, which is, you know, going to complain about every time. But we have access to expects, right? So let's pick a function where we can actually apply expects properly. So for example, update entity bitmask. Can we use, is there anything here that we expect as a precondition? I don't think so. I don't think so, because the map can be empty. We can have no entities. Hey bro, Shroot Swanson here. Hello Sarab. Shroot Swanson, yeah, I mean, that's I know that name from Discord, dude. So it's good to see you here again, man. How is it going? How is it going? I think it's been a long time since I've seen you here, dude. So I hope that you've been doing well, man. And I hope that you kept up with the practice, right? Yeah, so in this function, it doesn't really make sense for us. Let's just make sure. So this was supposed to update an entity in a entity bitmask, right? Oh no, it's not. So let's see here. So we call the entity update function here. We don't. This comment doesn't make sense anymore. We just get the. We're just trying to get the component index in this case, which we have that already. That's the bitmask. And what are we doing here? So we're saying if the bitmask was found, if the entity bitmasks. So if we haven't found it, then we set the entity bitmask to bitmask, because this is a new entity with a new component. That's fine. And if not, we just OR it with the result, which is fine. This is what bitmasks should do, right? So this is okay. Yeah, in this case, I don't need update entity bitmask. So fine, let's move on to the next function. So update entity component map. Now this is more of an interesting one, right? So what is this function doing? So given an entity ID and a bitmask, entity bitmask, which I suppose it's for this entity here, and given the entity component map where I store things, we're going to set the component data to it, which kind of makes sense as well, right? So existing iterator. So entity components that find entity bitmask. Yeah, so again, this doesn't make much. Yeah, expect inserted, yeah. Yeah, I mean, in this case here, we want to actually expect that we have inserted it in the map, right? Yeah, because insert returns a tuple of the iterator and the inserted. So we want to basically expect here. In fact, we don't even want to expect. It will be a different one. In this case, we actually want to do the other post condition thing. Because expect is a precondition, things that happen before a bit of code runs. And there is ensures, right? Ensures, which is a post condition. So this is the one you call after something has happened. So ensures, prefer, expect, yeah. There you go. So let's just read the core guidelines again, make sure that we're using this correctly. So reason, to make it clear that the condition is a post condition and to enable tool use. So character buffer max, mem set, okay, ensures that the first byte here is 0. Yeah, okay. Good. So in this case, we want to do ensures that inserted iter isn't the last or the end of my entity components, right? We're expecting it to have been inserted somewhere. And we also want to ensure that we have inserted. And this is a good use of it. You know, if you think about it, inserting into a denser map will rarely fail in C++. But, you know, it's good to make sure anyway. And the reason why we do that is because we make use of the inserted iterator afterwards, right? So because we're using it here without doing any checking on it, it's good to have a post condition here just to make sure it's never ever empty. That's all. Okay. Now good. I mean, that's a good use of ensures. Now generate entity ID, current ID. There's nothing we can ensure here. This is just a very basic operation in C++ where we just increment a number by 1. So there's nothing we really should ensure there. Now get might be a good contestant here for expect/ensures. So get's the reference to the component held by an entity. C, component class to get, entity ID. Okay. So the component ID is the type ID of C hashcode, right? And in there we find, we want to make sure that the entities, what is the entities again? This will store the entity component data. Interesting. I guess this is, yeah, we don't really care about this one anymore because we're not using this function. So I'm going to ignore it. I'm going to ignore that one as well. Because these are things that were left over from the previous iteration of my ECS. I do things a little bit differently now. I don't use the entity map anymore to store the components. I use a bitmask map. So, yeah. So ID, this function returns the registered component ID. If the component is not valid for this registry, then return it no locked, right? I don't know what Vim was doing there, but this was the one. So type info. Are we doing anything funny here that we expect something to hold true? So we have a hash code, type for hash code. If the type hash if the type of the hash is equals to my type ID hash code here, we return the type of hash. Otherwise, it's no locked. Again, I think this is valid because this is something that the user could call, right? So we want to make that check at runtime anyway. Nothing too interesting there. So entity ID, so set. Again, this is the old one. I'm going to leave it out for now. New set is the one that we really care about. So here we go. Index. Yeah, I mean, this returns a compile time issue now, but it doesn't hurt to add an expect here. So we expect the index to be something other than variant and parse, or in fact, yeah, so what does index of do again? Pass to work out the position of a type in a parameter, pack. Head of the type to find the index for, and then we have the head of tail, the current head of the parameter pack, and t's is the remaining types in the parameter pack. Now I'm pretty sure I wrote this in a way such that if the user calls this with a class that isn't in the registry type, so in my ECS components, this will return a compile time issue anyway. So I don't think I need that expect there. I can remove it. Now component hash. Yeah, what I could say here is that I expect, right, or expects index to be less than, or yeah, less than the type arrays dot size, I believe, right? Yeah, this is a valid thing here because then we're accessing you know, the type arrays through the index. So we kind of want this to hold true. And that's fine. This is only a debug. It's not really going to add anything to release the way it's configured right now. So this expect will essentially disappear in release mode. Okay, good. Now bit mask. It's 1 over the index, the current entity vector. I say that that's the end of the entity component. So in other words, an invalid iterator. And I say that if the current bitmask iterator, which is a find on the entity ID, if that is not the end, then we get the current component vector here, right? So if the current bitmask is not the end of the entity bitmask, yeah, so this is a good place, because if we have a bitmask, yeah, if we have a bitmask and we're trying to get something from the new entity component, which is my component stuff, I expect this to not be the final iterator, right? I don't know. But then I also do that check down here, so I don't know if I do need that expect in the end. Let's keep this up for now. I'm not entirely sure. Yeah, no, this expect is not needed. It's just a runtime thing here. So let's remove that comment and clean this up a little bit. Now, if we don't have a bitmask, we set the entity bitmask of the entity ID to the new bitmask. This will still be the end, which means that we set a new entity component and we say we update the thing with it. Yeah. Okay. Nothing wrong here. Let's go into this function and see how it's being called. So what is this function actually doing? So update entity component map. This given an entity and an entity bitmask, which relates to the entity. We expect, yeah, so this is a good one, right? Because we're passing two different things that are somewhat related here. We expect the entity ID or the entity bitmask to actually match the stored entity bitmask for that entity ID, right? So this is a good precondition that we can do here. So expects now. But somewhat I want to get the entity bitmask is the same as whatever my Irani, hello. Hello. Welcome to the stream, man. We're actually not getting much viewer duration, which is fine. It's a boring stream, I know that. But right. Yeah, we don't really have access to the entity bitmask here. Thanks. No worries, man. Yeah, I hope you're enjoying your Friday, and I hope you're ready to do some C++ with me. This chair is making me absolutely, like, my eyes absolutely hurt, and it's really annoying. I need to get a new chair. So for you guys that are starting out this coding life, I highly recommend that once you have some money, get a nice office chair, because it just improves your quality of life by so much. Especially when you start getting like back pains and you know, bottom pains because your chair isn't as comfortable, which is my case. you know, it can really cascade down to bigger problems in the future. But yeah, I'm hoping that you all have good chairs, and I hope that one day I make it on YouTube so I can buy a new chair as well. Let's have a drink to that, shall we? Yeah, so in this case, I don't actually have a way to check here, but I do want to check something like, you know, a bit mask, entity bit mask, and dot find ent ID, dot second. This is what I want to do, something like that. I'll leave that there. So existing entity iterator. So, right, so if the entity bit mask already has some components, what are the entity components here? Then we do this, otherwise we just push it back. Yeah, okay. Yeah, we've already looked at this function anyway, nothing to do here. So we were very nearly at the very end of all this work. So we were at the NuGet, right? So NuGet, what does this do? Before we actually, yeah. So we've looked at new set, and now we need the NuGet, which gets a component from an entity, right? That is actually very easy. So we get the bit mask for it, for the entity, and then we return the entity component for that bit mask. Right, so do we want to actually return something that's valid here? Because if we don't have any components for that particular bit mask, this is just going to return a reference to an empty vector, which is all right, I guess, but yeah, I guess that could be okay. Yeah, because if you don't know, in C++, this is for you guys who are just starting out in C++, when you do something like, you know, my map, .get, something like, you know, my key here, when you return something like that, now there's two things that could happen here. Either, and this is, you know, I hope that some of you in the chat that do C++ already know this, but I'm going to explain it anyway. So, and I guess this is one of the most annoying things in C++, right? Because it, you know, it's kind of behavior that is dubious. But when you have a map in C++ and you are returning, say, a reference to a value of that map, something like this in a function, so return my map here, there's two cases. So one, my map already has or has the my key entry in it, which has a value, in which case this will do what you expect. This will actually return a, you know, return a reference to my key value. Or, now this is the interesting bit, if you don't have a my key in the map and you try to return a reference to it, this will actually add, in line here, it will add an entry for my key, and the value will be the default initialized value, or the initialized type for that value, right? So the default initialization value for that type. That's what I'm trying to say. So this will still return something. It won't throw an error if it doesn't exist. So yeah, it's a bit annoying. But in this case, we're fine with that because, you know, if we return a component that is just empty, we're fine with that. We don't really care. So this is actually okay. So, right, bit mask in constexpr. What does this do? So we have a head and tail. This will get the bit mask for a particular type, right? So this is essentially like a std uint64 integer, where you may have ones and zeros set in the positions of where that type is in the parameter pack that we have, and that is it. So, you know, it's just compile time magic. Just take me on this, guys. Whenever I say compile time magic, don't try to understand it. It's too difficult. I don't understand it. You shouldn't either. But yeah, this does what we expect, really. I mean, we are returning size t here, and I guess what we want to do is we really want to maybe cache that. So auto yeah, I was gonna check that this doesn't actually overflow, but yeah, it's a little bit difficult to do that because index will return size t anyway, right? Index off, yeah, that returns a size t, so that's fine. what I do, yeah, maybe we should check that's not 0. It shouldn't ever be 0, right? We shouldn't ever get a 0 value from here. So for example, if the head exists somewhere, we got the index 0. So 1 to the 0 is 1. Yeah, so we should always have a bit mask that's kind of not 0, I guess. Yeah, so this is going to be in shorter compile time. I don't really care. But yeah, that was it. I'm kind of surprised that I didn't have more to do here. I'm kind of surprised that I didn't have to expect more things, just the way I've implemented things. So yeah, let's move on and make the actual library a little bit easier to use. Now, one of the things that not easier to use, let's make it a bit faster, shall we? One of the things that I don't like with the current ECS that we have is that essentially we have this massive vector, big vector, essentially, especially if you have like thousands of entities stored somewhere, where we store the entity data with the following layout. So it's a pair of entity ID. So for a particular component set, which may mean like a few components merged into one vector, that's fine. So you get a vector of pairs where we have an entity ID and a tuple that's actually storing the component data. Now, this is not nice. And I've explained before how this is not nice. And essentially it's because the size of this tuple is big. So if you have something like, if we have many components, then this stud tuple of optional of my C's here is going to be big. It's going to be very, very big, right? So I would like to kind of turn this into maybe a variant, right? So maybe we can bring back the variant, because a variant, if we have like a stud variant of many types, so C1, C2, all the way up to Cn here, the size of this has the size of at most whatever is the maximum size of my C's. That's what this is going to be. So this is probably going to make things a lot kind of smaller. But then we have obviously the disadvantage of not being able to know which variant will be in which position. So it implies that in the component map here, so in this map here, if we use a stud variant, we will need to store more than one entry per entity, right? In other words, say we have circle, or the bit mask of circle and square here, right? That will need to store some entities, right? So we'll have some, I guess, a vector of, yeah, so we're still going to have like a vector of variants here, where we have entity ID, and then the variant here, right? But I'm going to do this a few times over, so I will actually have to store 2 elements in memory. Oh, why did that not work? Why is my Vim not working? Come on, guys. Why could I not just yank it? There you go. So this is what we're going to have to do here. So the first one will be, the type circle. Variant is going to be resolved to my circle type. And the second one is going to be the square type. Now, this will inherently imply that we have some extra logic in the set, right? So whenever we do a set, we're just going to have to kind of move all of these values around. We're going to have to place them in the right order, which is difficult. And I'm wondering if it's worth doing it on stream, because I will get it wrong and I will probably get stuck. And in the end, it just means that you guys will not enjoy watching me. So maybe we'll move to something else, right? Maybe we actually try to implement something that renders something on the screen. But yeah, I mean, the key for this ECS, for those who are still watching with me and have been watching the series for like the past few weeks, is that we create a rendering engine. And that stream will probably begin next week. I'll create a new title for it. I'll create a new playlist where we develop our own rendering engine for graphics with our homemade ECS. So I'm going to leave that work for later on when I'm actually alone and, basically not being watched by 5 people and under pressure, because I will get things wrong. But today we can actually do some drawing on the screen with what we have here. So what do we have? Let's look at the ECS app. The ECS app doesn't actually do too much. We do have a draw function, which I guess gets called eventually. So let's try and like just build this and then see what happens. If I haven't made any compile errors anywhere, we should still work fine. So currently, we have something like this where we just draw like a square for each entity that we have, right? So let's see if we can actually draw a few things, right? So let's create a new, call it a system. It's not really a system yet. I haven't defined how I'm gonna declare my systems in the ECS. So the systems, for those who don't know, in an ECS are basically the functions that run on a particular component. So code, like behavioral code that's executed on a particular set of components. That's what a system is. If I got that wrong, feel free to correct me. This is what I've read online, and it kind of made sense to me. So what do we have here? So we have, for autoconst entities with circle, right? So we have all the entities with the circle here, and we have the registry get. So in this case, I'm going to use that new get stuff because it's just going to work better. But I believe it's a little bit difficult to actually call that right now. But yeah, we're gonna do this anyway. So what do we actually pass in this? So we pass in a registry that has entities with circle, rectangle, position, and color, right? So for every draw, we want to get whatever thing that we want to draw, for example, the circle and the position and the color as well, right? So we're going to draw circles with position and color, and we're also going to draw rectangle with position and color, right? And I guess for rectangles, that will be the top left. That will be my position, and the circle, my position will be the center. So yeah, let's do that. So let's try and get all of the entities with the circle using the new stuff, because this is like deprecated functionality now. Essentially, this is, registry.get is deprecated. In fact, can we actually use the deprecated keyword in C++ to actually... I know that there's a new keyword in C++ where we have a deprecation thing. So yeah, deprecated. Now, if we go into my ECS, what do we actually get? New get. So if I do deprecated here, will I get something at compile time? And also we have set, right? So the old set. So this is just a way for you guys to basically say that you're maybe going to remove this function in the future iteration of your library. It's worth using it in things like this, right? So I want to know what I get at compile time when I do that. I expect to see something like, there you go. It's a warning, set is deprecated. And it's very nice. It's very nice because I can see exactly where in my code I'm using that function, and I can replace it with the new calling, right? So create entity with component. Where am I using that? Okay, this is just in my benchmarks. Yeah, this is in my benchmarks. I don't really care about that one. This is also in test, but here. Warning get is deprecated. There you go. So we got a warning straight away, and that's the power of deprecated. Hello Ash, how's it going? Welcome to the stream, man. It's good to see you here. How's the code going? The code is going okay. It's going slow. It's going slow. It's one of those things that, it is a very kind of difficult problem to solve, and it's a difficult problem to get right at first. So I'm taking it slow, and for every stream we do something small. That's it. I've caught a few of your VODs. Oh, nice, dude. Yeah, I'm glad that you decided to join us after watching a few of those. So today we're actually gonna try and I guess we're gonna try and render something with the ECS, right? That's what we're doing here. I was going to try and replace some of the internal storage from tuples to variants, but I realized that that will be longer than I plan to stream for, and I don't want to stop something in the middle and then not know what the hell I was doing the next day. So yeah, we decided to do something a little bit easier in the stream. So right, so what do we do here? So we need to do a registry dot get or new get, right? Circle, and that is it. I think that's all I need. But yeah, so I get, basically this is a vector. It should really be a view, right? So let's add a comment here. This is, maybe we should return a view to the data instead. Yeah, I mean, this is essentially a view because we have a reference to a vector, but okay. But what is this? This type is a vector of pair of entity IDs and components. Okay. So straight away, I can get circle, I can get position, and I can get color entities, right? So I get all the entities here. Oh, drawable circle entities, right? That's what they are. And this should really be still a reference because I don't want to copy over that data. But then actually, I'm going to have to do a for loop on this, right? In fact, I'm going to move it out of here because that is a different thing. We're replacing this loop with a new one. So for auto const, this is a pair, I think, so entity ID, and if I'm not mistaken, what else do we get inside it? We get the actual entity component, which is a tuple. So we are going to go to entity or component tuple. In my drawable circle entities, or drawable circle entities, and we're going to do all of this stuff in here, right? So obviously we want to firstly get the actual components, right? So what do we have here? Out of interest. So this is a tuple of optionals, right? Yeah, it's a tuple of optionals. I do wonder if I should provide a new function to actually get to remove some of this work for now, because, you know, getting the actual entity component is a little bit cumbersome at the moment. So if you look at down here, I use my new get somewhere, and we can kind of see how cumbersome that is. Where's new get? Right? I do have new get somewhere. There you go. So this here, this is kind of what we want up here. It's very cumbersome. You kind of have to do something a little bit weird. So basically you get the component tuple, which is already up here. And with that tuple, you then get the first one. Yeah, so I'm going to basically provide a helper function in the ECS to do this, because it's a little bit difficult. I don't want people to think of this library as very hard to use, right? So let's do that here. So template, type name, C. So in here, we're going to return a C reference to entity or entity component. And we're actually going to pass in an entity tuple. Yeah, we're going to pass in entity components here. Or just a reference to it. And in here, we're going to do all that. magic stuff, right? So first of all, my component tuple, I already have that. I already have that up there. My component optional, yeah, so I need to get the index for that type here. So I think it was called compile time index of, I believe it was C and C's index here. And this is going to be const expr size t index. And in here I have index, simple as that, of my component tuple. So I got the optional here. Now I expect this to be true. So let's put an expect of my component optional, or just a component optional in fact. Just expect that to exist, and then we can do a return here. So return this. Just as easy as that, right? And I think this should be okay now. So if we go in here, we can just say registry get component. What was it called before? Entity component. We're passing the component tuple. Let me just make sure I got the signature of this right. I did. That's the circle component. And I just do the same thing for the other ones, right? So I have, what else did I get? Position component, and that will be position here. And then I have something else here, which is color. And obviously the British spelling, because we're just superior, right? Americans, you ain't got shit with spelling. That's what I'm trying to say. And yeah, so now color component should actually have all of this stuff that I've got in color. Does this compile in the first place? Let's see. I'm pretty sure that something will probably break. There you go. And let's just see what the first error is. Error, user of undeclared identifier, my component tuple. Yeah, that's right. It's what you get for using modules. You get IntelliSense not working for you guys, which is great. Now, did it build though? No, it did not build. So we've got one insert is deprecated, fine. Error, no matching member for NuGet. Which is interesting because it should be here, right? We've got that right here, so why is it not working? Registry.NuGet. So this candidate function template, not viable. This argument has type const may. Okay, so it's a const, right? I guess what we can do is we can duplicate this and then just return a constant reference to this that is also const in the class. Let's see. Now I suppose I didn't build either. No matching member for entity component. And this is the same thing. It's because we just got to provide that const variant of it. And we still got errors, so let's look at them one by one. Okay, is it because component tuple is const? I think it might be. Yeah. So is because of this one should be const really. Yeah. My bad. No warning, 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 warning. Where the errors are? Error. Did I see an error? Yeah, no matching function for bitmask. Yeah, bitmask. Why is that not const? Why is that not const? It should be const. Now we still get a few errors, but we'll power through them. Like, which one of you guys actually like the C++ errors? I wanna hear my C++ kings out there. Who looks at this and likes this? Because I do. I love it. Error. No viable overload operator for type uncle. Like, okay, so what is uncles? Maybe we can use uncle to return a const thing in there. So we need to look at the documentation, of course. Uncle, node dense, get. That would be something like that, right? I don't want to look at the license. Is another dense in there somewhere? So extract container API. So in addition to the standard unordered map API, see this. Yeah, let's look at the unordered map API. Wait, do you not have a const operator for maps in C++? Maybe they haven't implemented that in the uncode data type. Because it seems to me that this library here is just a mimic of the unordered map done more efficiently. That's what it is. But let's look at the operators and see. Now, yeah, there is no const operator here, which is interesting. But it's fine. We can change this, right? We can do something like we get a bit mask for that, entity components for the bit mask. Yeah, so this actually implies maybe it's a bug. Yeah, maybe it's a bug here. Because if the bit mask doesn't exist in the new entity components, I don't want to create it, which is what happens when you remove the const here. You're allowed to modify new entity components, and suddenly this makes sense because this just creates something. But if you want to provide a const version of this, then we got to make sure that we actually get the stuff, right? So we do something like this. Excuse me. Jesus Christ. Yeah, so what do I do when it doesn't? Yeah, I need to actually just put a note here. So expects that found is not the end of new entity components. This should be really a runtime check in this case. But we can't do that because we actually need to return a reference here. And I would rather return a valid reference and have an expect here than potentially return a reference to a vector that I create here and goes out of scope. That's empty, and that's not good either. So yeah. Let's try that now. I think that's a little bit better. Okay, so that compiled. Now, essentially means that I have all the color component stuff here. And this should really be a color, right? I don't know why IntelliSense doesn't work anymore. So color ID. So we have an ID for the color. Yeah. How are we drawing things here? So draw a circle, right? This is what we're gonna copy and paste here. So this function takes a center X, center Y. I guess that will be my position X and Y, right? So position X and Y. So position, position component since X, and this is position component Y here. Now the circle radius. Circle radius. I mean, I guess really this also comes from the circle one, so I don't really need position in here, but we leave it as it is, right? So circle component dot y, circle component, which is a circle that has center x, center y. Yeah, let's move it back then. We have the radius, and then we have the actual color here, right? So let's see if we can do that. So we have color component dot that, and voila, this is how you draw some stuff on the screen. Let's see if we are drawing the circles now. Oh, yeah, this is not a pointer. Now running the program, do we get circles drawn on the screen? That's something I want to see. No, we don't. We do not, because why? We actually get termination, and I suspect is because, yeah, as a GSL expects. So if we look at where we are actually... Yeah, it's in May ECS. What is this name mangling? Look at this stuff. Jesus Christ. That name is ridiculous. So we expect the found not to be the end of components. Interesting. So new get is, oh yeah, in this case I don't actually have anything in my ECS that has, yeah. See, it's a bug. It's not really a bug, it just tells me that I don't really have anything on the ECS with all those types that we're trying to get, right? So if we look at this, what we're trying to get here is the entities with circle, position, and color, and we expect them to be drawable components or drawable entities. But the problem is that in my registry, I don't actually have anything with all these types in it, right? I suppose. So if I do a new set in here, yeah, so instead of this, I create one with all these things in here. So new set, my rect. If I add a new circle here and I do my registry dot new set, I also need a position or my position. And if I do a my registry dot new set, the last remaining puzzle is a color, right? Now I have at least one entity, so this should work a little bit better. And just like that, we have no views again. Unfortunate. Oh, so we have an address sanitizer bug. Amazing. Yeah, let's take it line by line and see if we can get what the issue is. It's not there. It's not here. It's not there. It's there. It's on the collar. So why is it that on the collar we have an address sanitizer issue? Is it because it's taken a const reference to a component? Yeah, let's see exactly what that is. Why does it not work with our values? So we have this expect is free. This should be something. So the new bit mask is going to be something. We have a current mask iterator. That is fine. We have something that should return something as well, right? The new bit mask is 10 now. So we erase that. So it is the end of this. So we're moving things around to a new component. Ah, okay, so this doesn't exist at this stage. So this is something we haven't tried yet. Now this is a difficult one. Why is this not valid? So this pointer, the reference is not valid. Memory doesn't exist here, but why? So inserted iterator is valid, so it did insert it. Ah, yeah, it invalidates the pointer here, that's fine. What does it? Does it? No, at this stage I'm just expecting to see something like entity components the end bit mask. Is that going to be a bit better? I fear that the iterator is getting deleted at this point here, but I'm not too sure. So no, still a buffer overflow. I mean, good thing we compile with address sanitizer, right? What am I saying? So shadow bytes around the boogie address. So end bit mask. Okay, this is going to be a very difficult one to catch, I guess. I'm just going to have to stare at this for a while. Why is this a... What's going on here? I just wish that the output for the address sanitizer was a little bit more friendly as well. So entity components. That should return, you know, whenever I get something with a bit mask from entity components, that will be the vector of the entity stored. So I'm just perplexed here. I am just perplexed. Because we do insert a new vector if there is nothing in there. Now, is component data non-existing? It can't be, not at this stage, right? There's no way it's getting deleted before this. Let me run this again and see. So I'm not too sure now. So component data, what is that? Well, that's a tuple, of course. No value return for children. There's no way that's invalid, right? There's just no way. New entity component, what is that? Entity data.second. Maybe this logic is invalid after all, but the thing is how. So entity data, we erase this. Does that return me a const iterator? No, I think I should be actually removing this tuple after. Yeah, because entity data is invalid here at this stage. Right, what does erase actually do? Maybe we just don't know what it does. So vector erase, let's see what that actually does. I assumed it returns an iterator to the move stuff. Removes the element at position, removes the element, okay. Return value. Iterator following the last element, okay, following the last removed element. So it makes sense to, it doesn't really make sense to use the iterator to the last element because there's no guarantees that the object will still be flying around. So that's my theory. My theory is that this is the cause of the whole thing. So let's move away from this, and instead we have the tuple, we have the entity data here. Current tuple iter. We're going to do that, and after we update, we're going to remove it. This will copy everything though, I think. We'll solve that problem later, but then we do an erase on the current tuple iterator. As easy as that, I guess. Now, does this build still? And do we still get that error? Now we get an error even earlier, which is interesting. Yeah. It's not ideal, guys. Not ideal to have this. So we get the current tuple second. We set the optional at the index position to be the component value. So the component itself, the component data inside there. And then we pass that to this here. In component data. And it's got to be the component data that's wrong. It's just got to be that. Is there an easier way to move an element out of a vector? In an efficient way? Yeah, so maybe we do things a little bit more, what's the word? More explicitly here, right? So we do a entity component of C's, and then we have the moved we have something like this, right? And in here we can do the gap on the moved component. And then instead of this, we pass the moved component there and see if that solves anything. I have very low hopes now. I don't know if this is going to work or not, but we will see. Huh. Amazing. Why the hell is this going on? Why? So it's in the main app set, which is that line there. In this line here, and it's actually in the insert. What? The insert is the issue. That's a new one. Let's run this again. The first insert was fine. Second insert was fine. Still not convinced. It says that the insert is the issue, but why? Yeah, no, this is the line. This is definitely the line. In insert, in place, move value. So whatever value we have here in insert, this is so messed up. Like, why is this not working? Why is insert actually causing me? So insert value returns a pair and iterator. Value type. What is the value type? Is there a better way to insert things in the map? Segmented map, the unsegmented set. Uncles on other dens provides a custom container implementation that has lower memory requirements than the default stud vector. Memory is not contiguous, but it can allocate segments without having to relocate and move elements. In summary, this leads to much smoother memory usage. Memory usage increases continuously, that is. No high peak, fast insertion. I just want to look at the inserting thing. Inserts. Whenever an element is added, it is in place back to the vector. The key is hashed and an entry bucket is added to the corresponding location in the bucket array. All right, we're struggling here. Why does insert fail? And it fails right here. In place move of value. Is this the one? No, it can't be. Value type value. It returns a pair of iterator and bool. Okay, fine. What if I do something like this? Entity component, the ent bit mask. Equals that. And I comment this out. Is the insert function kind of cursed? Oh no, because I need the iterator there. Ooh, yeah, I need the inserted iterator, don't I? Oh no, I don't. I don't need it at all. That can also piss off. Do I still get those issues? No, I get a different one. Amazing. Right on the first set as well. I did build it, right? Yeah, this is the joys of working with C++, guys. Sometimes you're going to hit an address sanitizer issue and you have absolutely no idea where it is because the logs aren't very useful. Even if you try really hard, really hard to read them like we are now here, it's difficult to figure out what actually is the problem. I mean, I know that it happens in this call here, and I know that it happens in here. So entity components bit mask. And I also know further that it fails in another dense is somewhere another dense implementation somewhere, like this line here. But yeah, it is not ideal. Not ideal. Not ideal at all. Entity components.find. I have a suspicion that it's giving me the wrong line. It's definitely this one that's failing on. But why is a pushback not working? What if I just remove that? Because theoretically, this is gonna, create the entity bit mask array anyway. But it doesn't. It doesn't work. So on the first insert, entity components doesn't do anything, right? So we have no values here. On the second time we come around, they should have some values. So I expect to see some values here, which is 0, second, whatever. Now we want to insert 3. And that's when it falls off. But why? Again, on the first insertion, we have no values. Nada at all. And the second time around, we have a value of 0, a value of 2 here, which I believe it's like circle, the circle component or something. But then we try to add 0 again, push back. And the component data. And the component data is the moved component, which came from here. I'm not sure if this std move is doing anything, potentially even harming the code. I don't know. No value return for children. I don't know what that means. What is component here though? That is the actual center stuff. An std index should actually assign things properly though. Yeah, I have no idea. Guys, I'm falling asleep unfortunately, so I'm going to call it a stream here. I'm going to try and solve this on my own time. To be honest, I have no idea what's going on. This is it's going to be a hard to debug address sanitizer issue. It's probably because I'm passing a wrong iterator somewhere when I shouldn't be. And yeah, I think we're just going to call it here, guys. I'm sorry. Sorry to disappoint. Today has been a very short stream. We haven't actually got that many viewers today, but I hope that the people watching this in the future will understand the struggles anyway. But that's it. I still have bugs in the code. I have not managed to remove all of them. I will do that in the future though, especially now that we've got some access to some expectations. So maybe I need to add a few more expects in places where I'm passing tuples around. Thanks, have a good rest. Thank you, Lord Hog. Thank you for joining the stream, man. And I'm going to try and make a stream that's a little bit more interesting next time, where we don't get stuck on the bug. But anyway, bye-bye. Ciao.